Hello, my name is Maciek Wasiak, and I am CEO of Xpanse AI. Thank you very much for inviting me to this conference. Today we'll be talking about the anatomy of a successful data science project. This is the agenda for this session. I will quickly introduce myself, then we'll talk about the data science failure rates, then we'll talk why is it failing, and to do that also we'll need to go through the data science process, and then there will be some closing thoughts at the end of it. So quickly about myself, I was researching AI in academia in ancient times when there were very little applications for it. After that, I spent 10 years implementing AI, or what it's called now, data science, commercially. And in the last 5 years, I've been leading an AI R&D startup where we work on automating a lot of data science workloads. So, a couple of reports from last few years about data science and the astonishingly high failure rates, which if you look at the timeline seems to be increasing, so it looks like it's getting worse, not really better. And I think it's worth talking about what's going on and why is that happening. And there's actually a reason, and the reason is not necessarily what everybody thinks about this. To explain that, we need to go very quickly through the history of machine learning and databases. And if you look back in the 50s and the 60s, the databases usually stored the data in one big table, resembling pretty much an Excel spreadsheet. And when you were trying to execute any of the early machine learning algorithms, then they were taking data as well in a form of this singular one table. And then what happened in 1970, one guy from IBM invented what's called now relational databases. And he proposed to break down these large tables into multiple smaller ones, which would help to manage the database, would help to avoid duplication, and every database would become more stable. And as you follow these so-called normalization rules for databases, you just create more and more tables when you design a database. However, if you look at machine learning, it still takes data in this archaic format. It's one table with vectors, and there's no way around that. And it creates the situation, it's at the source, at the bottom of major problems, because while databases are good for operations, anytime you want to do any ad hoc analytics, and that includes data science, everything takes a long time because analysts or data scientists need to tap in to these multiple source tables and convert them to one table before they can start any analysis. And the process of delivering data science and predictive models is quite different to typical analytical processes. So now is the time where we can look at that a little bit more detail. This is a classic overview of the process. It's called CRISP DM. It's a shortcut for a cross-industry standard for data mining. And it's over 20 years old. And it's not like it's obsolete. It's actually quite good. However, for people who don't know what's going on, it's hard to understand really, what is business understanding? What is data understanding? What does that mean? So we have created a new take on this process that focuses on main failure points, which is the topic for today. And it starts with defining business problem. And this is not where we just decide, or are we going to go after cross-sell or upsell or churn or fraud? No, it's actually much deeper and much more difficult step. And this is where, say, you already decided that you are going to analyze and build model for customer churn, for instance. But this has implications because if you want to analyze customer churn, then you need to define first who your live customer is. And there could be multiple definitions in an organization. And it's down to the project owner now to decide, well, what kind of customers are we interested in for the future predictions? And it could be, for instance, only high-value customers, right? Or only customers who joined us last year. So this has implications for entire project. Once you do that, then you need to define, again, in business terms, well, what does it mean that those customers historically churn? Are we talking about, they gave us a phone call that they are leaving us? Did they stop visiting our store? Did they port their number to another operator or move the services, which would make things quite easy to understand? Or maybe it's a value churn where they just decreased spend by more than 50%, maybe more than 80%. This needs to be defined by the business, typically with the help of data scientists. The challenge here is that very few people typically have understanding of how to do it and how important this step really is. Now, the next step is for data scientists to take this business definition of the problem and convert it to a piece of code that will label, in this case, in this example, our customers historically, who was live and who churned and when, and who didn't churn and when. And this task often is surprisingly challenging for the reasons we'll speak in a moment. Next, there comes this data preparation step that I mentioned before, where someone, and typically data scientists, need to tap to the source database and transform this data from multiple tables into this one analytical data set that is consumable by machine learning, because machine learning cannot build models on multiple tables. Only then, after that, we can run machine learning algorithms. After that, there is a very important step of essentially selling the models to the business. And if the model is approved, then we can move to model deployment. Now, just to complete that process, it usually starts with a database. Then the first three steps aim at obtaining correct analytical data set to give the machine learning the best shot. Then once the model is built, we are connecting it to the database. Just to add some effort split here. So we spend a little bit on the first two steps, and then the most of the project time is typically spent on preparing data for machine learning. And I think many people who listen to this heard that 80%, typically 80% of the project goes into data prep. So that's exactly these steps where we need to understand what are we doing. We need to label the data historically, and then we need to transform it into a form of machine learning ready analytical data set. Then there's a little bit of time for machine learning. It's usually just a day or two, maybe 5 days tops. It doesn't take long. Then we spend a little bit of time, talking to the business about what we found, and then we can move to model deployment. Now, in terms of the failure points of this process, it may fail at any stage. Very few people really know how well to define business problem for predictive analytics. Data scientists have very little experience in transforming this problem into a data problem. Then data prep takes so much time, and there are always pressures on data scientists to deliver other things as well. So they often get stuck, and projects often get essentially abandoned at that stage. But if they go through it, then there is a chance to do machine learning. And probably machine learning is the least failing point because it's pretty well understood. It's taught at universities. There are many courses about that. But if it's done, once it's done, then data scientists again often fail during the review meetings with the business when they are known for their poor communication skills, no matter what they think about themselves. And the business just not buys. They don't buy into the model, and the model is not scheduled for deployment, or worse, is deployed but ignored by the business because of the failing in communicating the findings. And of course, it can fail also during model deployment because so few projects actually get to this final stage. There's very little experience, and usually we are out of budget at that stage, and all of a sudden we realize we need another 2-3 weeks to deploy this model to production, and we don't have that time. And someone might ask a question: why is it that these projects fail at these stages? Like, what's wrong with the world, essentially? Why are these projects failing at any of these stages? Well, here's the thing. This machine learning part, this seems to be on everybody's focus. So this is what academia is teaching, and they practically don't teach anything else. They don't teach how to define business problems, how to label the data, how to prepare the data for machine learning, because they don't work with databases. However, they have tons of analytical data sets, and they usually start their teaching with analytical data set. So these 3 previous stages are essentially not covered. And then after machine learning is done, obviously there is no business to discuss the findings with, so no one knows how to do it. And there is no database to deploy the model on, so it's not covered as well. And it's not only in academia, online courses as well focus on machine learning. For those of you who know Kaggle, Kaggle is a competition site for data scientists. It's full of analytical data sets. And it also contributes to this skewed view of what data science is about. And this is what people talk about on conferences, about machine learning. And obviously, if you put all these things together, then you realize that data scientists also focus primarily on machine learning. And for many data scientists, this is how data science process looks like. It's just machine learning. And when they go into the real life and they realize a lot of things need to happen before, and they don't even know what these things are, this is when they fail, because they attempt to do something that they haven't been trained to do. And they have very little understanding of what needs to happen and what they should do. So ironically, many data scientists go for years with this job title, but not even starting on their first predictive analytics project. And once they start, they fail. And if they don't fail, then it takes so long because they need to do other things as well. Some closing thoughts then. Applied machine learning is indeed what defines a data science project. However, once you decide to use machine learning, then it requires a lot of non-machine learning work. And mainly it's caused by this disconnect between the database world and machine learning world. Academia and data scientists are absolutely obsessed with machine learning, and that's causing, lack of interest in everything else. And they don't have knowledge, they don't have skills, or sometimes even awareness of what needs to be done in order for the project to succeed. And obviously, all that leads, unsurprisingly, to astonishing failure rates. That's it from me today. Thank you very much for your attention. Feel free to link with me on LinkedIn, and maybe see you in real world some other time. Thank you very much.